and then we will, at the high level, talk about each particular stage. Okay, so first we will have a quick look at the brief look at the 3 stages of the app development, and then we will go to stage 1, how you are to conceptualize the application. Stage 2, how you would go about developing the application, and stage 3, that's when you put the app into production, and then what you would have to do from that point onwards. And then naturally, as we go through the items in this workshop, you're going to have a lot of questions. So there are 2 things I have to say about that. Number 1, there will be a slide where I will tell you where to go after this workshop. And number 2, there is a new Slack channel that we launched specifically for you to join after we've gone through the items of this workshop, and there you can ask your follow-up questions. Okay, so let's begin. There's quite a lot to talk about, so let's go through these slides quickly. Okay. Now, many people, of course, have asked us about the Coding Bootcamp, which we're going to run again in this January, but that's something we will come to afterwards. So if you're here for that, for this subject, about the contents of the Coding Bootcamp, stay with me until the end and we'll address this also. Okay, so let's look at the stages of app development. Roughly speaking, this is what you're looking at. In the concept stage, this is before you've done any design, before you've even touched a line of code. Okay, this is where you would discuss the basically the problem you're trying to solve, your target audience, the market in which this application would potentially be released, and that kind of thing. And then once you've established the problem you're trying to solve, you then go into the idea of prototyping, designing it. Okay. Once you've done that, you move on to development. That's where you actually start to get to coding. Okay, and we will talk about topics like MVP, how programming is done in a team specifically. Okay, this is not about you becoming a software developer or learning how to code. We've done workshops on that. We can check that out later, but this is specifically how a team would go about producing an application and how testing is done. Then we go into production. This is where the application is actually live, and you have hundreds of thousands of millions of customers interacting with the application. And this is where you, for example, collect data about your customers to know who they are and how they're interacting with your application, and beyond that, like customer support and payment gateways and invoicing and that kind of thing. So we are going to be focused mostly on the technical aspect of these 3 stages. Okay, but let's move on to the next item in our workshop here, and that's of course the first stage. Let's look at the concept stage and see what's involved here. The first question you want to ask, if you are building an application, if you intend on building an application, is why are you building an app? What exactly are you trying to solve here? Does an app for that particular problem not already exist? Do you know, for example, how this app is used, if it's necessary? Do you know, for example, generally speaking, do you know your target audience well enough before you actually build your application? Do you know who you're trying to solve this problem for? So that's the first thing you need to check off the list. Okay, so you need to know your market before you actually even talk about producing something. Assuming you know your market, Assuming you know the people for whom you're trying to solve this problem, the next question is, do you even need an application? Do you like actually need to build an application for this? There are many people who sell products online, who do consulting, who provide different kinds of products and services without even, touching a line of code. I mean, if you go to Instagram, you'll find so many people who are selling their products online. Amazon, for example, it doesn't take much for you to, technically speaking, in terms of, coding skills, it doesn't take much to have a store on Amazon. Facebook, even I know people, companies who through their Facebook page are able to sell their products and services, so they don't even build an application. You want to talk about building an application only if there is nothing out there that can, that there's a problem and there's no application that can solve that problem. Okay, but once you've established that, actually, you know what, there is no product that exists currently, and the only way we can solve this particular problem is if we actually, produce a product. We actually develop a test it, create buy a domain for it, and have people go to that website or download that app from the App Store, and that's how we solve the problem. You then want to talk. Then now here it's at this point that we get into the technical details. It is at this point we get into the technical details. For example, the starting point is these people who are going to use the app. Where are they going to be? Where will they expect this application to be? Are they going? Is it going to be primarily a mobile application? Is it going to be preferably on the web? Or is it going to be does it have to be a desktop application? Okay. Now, we're going to look at applications that would generally be found across the different platforms, meaning they have to be available on your phone and your web, because obviously that's where that's where most people expect to find your application. Now, there are some applications that by their nature have to be limited to a particular platform. So, for example, if you talk about games, like very high graphically intense games like you would find on a PS4, PS5, and obviously you're limited to that particular platform. The Xbox, PS4, PS3. If you're building software for embedded systems, for example, like an ATM machine or a vending machine, then you're limited to that platform. But here we're not talking about those applications. We're talking about social media apps, e-commerce apps, kind of thing. But keep this slide in mind. Take a quick look at this, these primary platforms, because I'm going to tell you which technology to choose depending on the platform, for which you have to build an application. Okay. So let's talk about the concept stage again. And here we're talking about designing it. So at this point, you know the problem you're trying to solve. You know the people who are facing this problem. You know where they are. You know how they use their phones. And now you want to build an app for them. Obviously, before you actually begin the coding, you start to design the interface. But before you design the interface, you want to plan out the journey of the user. Now, I don't know how many of you are designers, by the way. I like to quickly survey people. If you're a tech person, meaning you've actually you have some familiarity with code, type in tech. If you're not tech person, meaning you've never touched a lot of code, just type in not tech, and I'll come back to that later. So do let me know. I like to know what kind of audience we have here. But the word UX and UI are not the same thing, unfortunately. And this actually bothers people who are who are UX experts, they're bothered by the fact that these two words, the UX and UI, are used interchangeably. UX means user experience. UI means user interface, meaning the components with which the people interact, whereas the user experience is more high level. So for example, UX can, you can apply UX, for example, to the layout of a particular bank branch. For example, the entrance of the bank, to the seating layouts, to the machine where, for example, you press the button and it gives you a token and you wait for your turn, to even where you would, for example, place these screens that display your token number. Okay, so the UX is about high level, whereas UI is more specifically about the user interface. Okay, but this is where you begin. You begin with the user experience. Before you talk about which technology, before you talk about programming languages, you talk about the user experience. Okay, and of course you would know the user experience assumes that you know what platform your users are going to be on: mobile, desktop, web, or like I said, even a gaming platform. Okay, now look at this screen. This is how the design stage would go. Okay, just a quick look at the screen. We'll come back to it later. But here's how you would begin. And this is based on two principles. The word or the idea of MVP, which is minimal viable product, and something called agile. I'm pretty sure you've heard of these two words. Even if you don't know specifically what they mean, I'm pretty sure you've heard of these two. I will clarify what these two things mean as we go through the slides. But look at the screen. You will see here that we have this this drawing, this sketch, which looks like some kind of phone screen, like maybe a login screen or a registration screen or maybe a download screen. So you have this sketch here, and then in the preceding, and then in the image next to it, we have something that looks a little more clear. You have some clarity about what this is. So for example, here we have the word logo, and then here we actually know what this button is supposed to be, and you have some dummy text. And then after that, we have the actual design. This is how you would go about developing the user experience of this application and the design of this application. Let's look at this idea a little more in more detail. In that previous slide that I showed you, that sketch is what we call a low fidelity design, or lo-fi for short. Okay, and here's how it works. Basically, your UX expert, who may also be a UI expert, will roughly sketch. So basically, here's how it works. If you are the product owner, if you have a client, you talk about, for example, you brainstorm. This is basically a brainstorming session. Okay, and maybe you produce a document, or you go to the whiteboard and you write down your ideas, like the user should be able to do this, the user should be able to do that, they should be able to register easily, they should be able to download this. And according to this, informal discussion, the designer or the UX expert will produce a low fidelity sketch of the components that would facilitate this user journey. Okay, so for example, they would draw a screen, it can be even on a pencil with paper. Now, there are more advanced tools, which I will come to later, but it can be something as simple as a piece of paper and a pencil. And they would draw out. So for example, they would click on this button to register. They would click on this button to log in. They would click on this button to go to the dashboard. They would click on this to see their, let's say, their subscription. They will click on this to, for example, go to the checkout gateway and so on. So you draw out these screens in a very rudimentary way. And then you would look at those screens again. You would sit down with the designer and say, hey, you know what, maybe the button could be a little bigger. Maybe we can make the text more prominent. So you go through this cycle: feedback, reproduce the low fidelity design, feedback, reproduce the low fidelity design. And then once you have once everyone looks at the sketch and they go, you know what, this looks good enough, let's take it to the next stage. That's where you produce the high fidelity design. Okay, this is where you, what do you call it? Clean it up, basically. You fix the margins, you decide what will be the appropriate font face, whether you want to give, for example, a curvature to the buttons. Basically, design the application in such a way that it fits your company's brand. Okay. Then, once these high fidelity designs are produced, these designs will be then passed on to the development team. And I will, in the subsequent slides, I'll show you what that development team would look like. But this is the idea. If I go back to that slide, this is the idea. You start out with a rough sketch. You iterate over it. You keep improving upon it, and then once you're happy with what you have, you start to clean it up. And this layout, this cleaned up layout, will eventually be where your logo would go, the final text would go, and the developed components, the components that the developers develop, it will go into those indicated areas. Okay. Now, let's see what the development stage will look like. Now, this is a big topic. This is a big topic. There are different approaches to going about developing. There are specific details that we'd have to we could go into further, but I'm trying to give you an intuitive understanding and try to limit the technical details so you at least have an idea about this particular stage. Now, let's quickly talk about methodology. And there are currently there are two very popular methodologies. There are others, but these two stand out among others. One is called Agile. The other one is called Lean. Agile, this methodology for developing apps. Now it's even used for developing products in general. It doesn't even have to be digital software. It's used. It's an approach that companies take for developing products. But it was originally what do you call it? Or it was originally created for software. Like the people who authored the textbook on which this methodology is based were all software engineers. So we reached a point where producing software became too complicated, and long story short, they wanted to create an efficient way, an organized way for anyone who wants to build an app to build an app in an organized and efficient way. Lean, on the other hand, was this concept originated from Toyota Motors. Toyota is a company that, and they've established this methodology for innovating or making it possible for themselves to innovate their product, which is their vehicle. Now, which methodology you choose depends on your priority. And it basically comes down to this. If your goal is to innovate, if your goal is innovation, you go the lean route. Okay? If you go down the lean route, you're not concerned with time. So time is not necessarily a priority. It's innovation. It's being at the forefront. It's being bleeding edge, cutting edge. If, however, time constraint is your priority, then Agile is the way to go. Okay? Our discussion will be based on this methodology. So let's try to understand this again intuitively without getting too much into details. This is one of the approaches to Agile. So I told you that there are two primary methodologies to go about producing products. There is lean and there's agile, but within agile, there are also different ways to go about being agile. The two main ones under agile are Scrum and Kanban. And Scrum is the more popular one. And here's how it works basically. Going back to that idea of brainstorming, where you're sitting down with, let's say, the product owner, which could be the client or the CEO, the designers, you produce a backlog of features. By the way, even the software developers ideally should be involved in the first stage. In the brainstorming stage, they should be part of this process. This is an important detail, which I'll come back to later. But what you do is you first produce a backlog. All of the features that you would want to go into this application will be in this backlog. Whether they're small features, big features, standard features, or ambitious features, they will go in the product backlog. From this product backlog, or based on this product backlog, you would then have something called a sprint. A sprint is basically a certain time frame, a fixed time frame in which certain items from this product backlog would be selected, ideally the high priority ones. For example, if you're building a social media application, probably the most important feature would be the feed, the thing with which the users are going to interact with. And features like, for example, where you could upload your picture and crop the picture and be able to rotate it and turn it from grayscale or give it some effects like you have on Instagram. Maybe that's not so important. Okay, they can just upload their picture and be done with it. So based on you would prioritize this backlog and you would select some items that you would be able to complete within a sprint, within a time frame. A sprint can be 1 week, it can be 2 weeks. To some extent, it's arbitrary, but it has to be fixed. So once you go through this sprint planning where you choose the items you want from the backlog, you actually, you start to develop, you start to work, you start to put those items into your, basically you start to work on the items in your sprint backlog. So if it's 1 week, in that 1 week, you start to focus specifically on those particular items. If there are 10 items in your sprint, then you will work on those 10 items. Then, once you've completed your, as you're going through the sprint, every day you are going to have what is called a stand-up session. Now, it's not in the slide, but you will have a stand-up. So basically, every day, when you complete some tasks, let's say you have 10 items, on day 1, you finish 2 of them. The next day, you, the designer, the scrum master, the project owner, the product, the manager, all of you will stand together in a 10-15 minute session and talk about what you've accomplished. It's very short, it's very informal, but it's a process in which you always have feedback and everyone knows what's going on. Okay, so you're not working in silos. That's one sprint. Once that sprint is complete, you then have a sprint review. So at the end of that 1 week or the end of that 2 weeks, everyone sits in a meeting room, or you will have a Zoom session, and you would go and you dedicate that day to talking about what you accomplished, whether everyone's on the same page, because it is at this point where, for example, miscommunication will become evident. If, for example, the designers design something and the developers develop something, whereas the product owner was expecting something entirely different, this will become clear immediately. And then you can go back to the sprint planning. And it can be about whether you would proceed to the next sprint, proceed to complete the next items of the product backlog, or no. Go back and revise and fix any mistakes that were made. Okay, so this is why Agile is so popular. It is very simple to implement. You know, it can be accomplished with some informal discussions and some even basic applications that you can use to sprint planning. And I'll tell you, and I'll suggest you 1 or 2 of them. And it makes it possible so that you're constantly communicating with everyone involved. Everyone is involved, not just the tech people, not just but the developers, the designers, the project owners, the project managers. Everyone's involved every day. Okay, so it's perfect. Expectations are managed. mistakes are avoided, and basically everyone's happy. And the Scrum process basically comes down to something like this. The Scrum board. I will come back to this in a second, but it comes down to something like this. So this is your backlog. Okay, this is your backlog. This is the list of all of the things that you want to, all of the features that you want to integrate into your applications. Everything that would go into the final product is in the backlog. Okay, then from this backlog, you would choose something we call stories, which are, let's say, for example, features that themselves are composed of smaller sub-features. So for example, one story could be a registration screen. But building a registration screen has smaller tasks like creating forms, creating buttons, getting the buttons to work with the forms, taking the information from the form and sending it to some server somewhere for it to be saved to the database. Okay, but basically once you have your stories, you break them down into their smaller, into the small subtasks. Okay, this is your to-do list. This is what you would do in one particular sprint. And I said the sprint could be 1 week, could be 2 weeks. It's arbitrary, but it's either 1 or 2 weeks. Then here's how it would work. Now this to-do list is for everyone. It's for the project manager, it's for the developers, it's for the QA, it's for the UX and the UI, for the UI designers. So what they would do is every person would take an item from the to-do list and move it on to the doing, bring it to the doing, for example, list. Why do you do this? Well, every time someone takes an item from the to-do list, we know who's doing what. So for example, if someone needs to work on the register button, we won't end up in a situation where 2 people are working on the same thing and we waste time. So when someone takes an item from the to-do list, what item has been removed, and we know, for example, that someone is doing this item, maybe I can move on to the other one. So it's a great way for everyone to be synchronized and be on the same page. Once you finish an item in the doing list, okay, that item will be put into review, and that's for someone to verify, for example, that this button has been completed properly. It's been done according to design. So for example, the graphic designer could look at the end product and say, wait, this is not how I designed the button, please go and adjust it. Or for example, the QA can click the button and say, wait a minute, this button is not doing what it's supposed to. And then we can put it back into the board, and the person who's responsible can fix it again. And of course, if it's been verified, it will be then put into the done stage. This screen, this board, this Scrum board, everyone has access to it. Everyone knows who's involved, which particular task is assigned to whom, and so everyone can keep track of progress. Everyone is in the loop, basically. Okay, now let me come back to this screen because I want to make an important point. This screen here illustrates the ideal team. This is the ideal team. This is the ideal team that you want to have. I'm not sure how many of you have experienced building an app of your own or hiring someone to build an app for your own. If you haven't experienced building an app, either because you did it yourself or you hired someone, type in developed, otherwise type in undeveloped. But here's what that experience would look like. You would hire someone, and like a freelancer, for example, or even an agency, they would I think, let me tell you the roles that these members will play, and I will come back to this point because it will make more sense then. Here is the ideal team. Okay, you would want at least, the reason you want to have at least 2 is because of a technique called pair programming. Now I will keep this description basic, but here's how it works. 2 developers, listen to this part. 2 developers share the same computer. This is a crazy thing to say, and when I first heard that I had to sit next to another developer and actually share the same computer, I was like, what do you mean you have to share the same computer? I mean that exactly. Two developers put a laptop in front of them. One has a keyboard and a mouse or a trackpad. The other one has another keyboard and a mouse or a trackpad, both connected to the same computer. And here's the idea. As one developer is writing the code, the other one is observing. The other one is observing. You see, when you're developing code, sometimes you get stuck on a problem. And when you do, it can be you will be able to notice that problem immediately, or you'll be stuck on that problem for hours, and sometimes you may even give up and say, you know what, I'll try this again tomorrow. Or you might get bored together, or you might get bored altogether, and you start to go on your phone and you start browsing Facebook, Twitter, whatever, and basically time's flying. Meanwhile, alternatively, or rather, let me come back. When you have pair programming, that other engineer is like a second pair of eyes, another brain that is able to point out the mistake that you've made and say, wait a minute, you made a mistake over here, or you forgot to do this, you forgot to do that. Now, of course, developing is both a creative process, but it can also be laborious, meaning you can get burned out in a single day of work. So what happens is when you do get burned out, what you do is you sit back and you let your partner take over. And then you are the one who becomes the observer. You're the one who is watching, making sure, helping them get through the task. If they make any mistakes, you can point them out. If they forget to do something, you can point them out. And basically, this is how you both would help each other out. Then we have someone called the QA engineer. The QA engineer is a software engineer. They're a software engineer by training, and their job is to use their software skills to test the components that those two software engineers have developed. The role of the QA engineer is to test the quality of the components that those two software engineers have developed. Okay? The UI and UX. Now, one more point. I've put the UI UX in this cluster because it's important. Why? Because the software engineer, the UI designer, or the UX expert must be directly in talks with each other. They must collaborate directly, because sometimes the UI designer may design a component, or even if they're doing the UX part, they may plan out a certain journey that may not be technically feasible, or it might take longer than they are willing to, it might take longer than the product owner is willing to accept. So the software engineer say, this component you designed, it might take this much time, it might take that time, we could do it on this platform, we cannot do it with this platform. And the UI and the UX person may be able to make adjustments accordingly. Okay. On the other side, on the very other side of the screen, we have the project manager and the product owner. The project manager, sometimes the Scrum Master can also take this role. So one person can actually fit both shoes, but ideally you would have a product manager who is someone who's able to talk to the product owner, someone who's able to communicate with the product owner and able to extract information from them, able to understand what they want. And the project manager is the first point of contact with the product owner. So rather than having the CEO of the company or the client, stand behind the shoulder of the developer and say, hey, I don't like how you did the button. The project manager is someone who, is supposed to manage expectations of the client or the board of directors or the CEO or whatever. The person who's supposed to be the recipient of the product, basically. The Scrum Master is the one who facilitates the Scrum process. It is the Scrum Master who is responsible for the Scrum board I told you about. It is the Scrum Master who's responsible for ensuring everyone shows up at the daily stand-up. It is the Scrum Master who's responsible to make sure everyone shows up at the sprint planning. It is the Scrum Master who's supposed to highlight any let's say, obstacles, any glitches. If the software developers are working on some piece of code, and let's say they're trying to integrate logging in to the application through your Google account, and then Google releases some changes which could postpone or delay the work. The software engineers will tell the Scrum Master, and the Scrum Master will then facilitate the communication with all the entities. So for example, they will say, hey, we can't do Google for this particular sprint. What do we do? And they will have discussion. Everyone will be involved at the table, and we can tell the product owner, hey, maybe we can do it at the next sprint. Or for example, if you absolutely need it, we can take items from the current sprint and postpone those. So the Scrum Master is supposed to facilitate communication between all of the members. Okay. Many projects fail. Many projects are delayed, or they incur costs because a person is trying to fill in multiple shoes. If you're a freelance developer, for example, I can tell you that you have probably unknowingly, you've tried to assume multiple shoes. For example, the shoe of the designer, the shoe of the QA, and the shoe of the Scrum Master. Meaning, if you have a company, for example, if you're an agency and you've hired a developer, you may not know it, even the developer may not know it, but they're actually trying to fulfill multiple jobs. Not only do they have to know how to code, not only do they need to know how to, for example, design, they also need to know how to manage a project. They also have to be the person who has to communicate, obstacles, defects, or additional requirements. And if you're a software engineer by training, maybe communication was not something is not a skill that you've acquired, and because of this communication breakdown, these problems start to snowball, and eventually the project either falls apart, it takes forever to develop, or the final product is just disappointing. Okay, like I said, this kind of system is not always doable, because you have to hire experts, you have to interview them, make sure, it's a hiring process. That itself is even the process of hiring someone is something to take into consideration. But if your expectation is if you absolutely are intent on producing an application that will be used by many people, it will be an application that people will actually go to the Play Store and download. It will be an application that people will actually subscribe to, meaning they will pay you to use the application, and you have something very clear in mind, then you need to be able to facilitate this. This is important. Having the right team is absolutely important, and you cannot put the responsibility of developing application on the shoulders of one person or two persons. Okay, so keep this in mind. And if you're not able to do this, then at least you will be able to manage your expectations. Either increase the timeline or reduce the number of features you want to put in the application. Okay, let's move on. Now, stage 3. This is where your application has been developed, meaning it's like you have a working prototype. You have a working prototype. Either you as a developer have a working prototype on your computer, or your development team has a working prototype on their computer or on their phone. Like you're sitting in the office and you're able to interact with it and see, see it. How do you go about putting this application in production? Okay. First, let's establish define three terms. Three terms that are used in software engineering: working environment, staging environment, production environment, which was even in the title of this workshop. Prototyping to production. Production is where you're actually live. When your app is in production, it means it's live, meaning if someone types www.myapp.com and they see the app, that app is now in production. Everyone in the world can see it. Everyone in the world can download the app on their phone and interact with it. The working stage refers to, or the working environment rather, refers to the developer's computer. The developer's computer is what we call the working environment. As when the application is running on the developer's computer, no one else can see it, only the developers can see it. Or you would come and sit on, grab a seat next to them and look at the screen. That is what we call the working environment. And then let's say at the end of the sprint, that 1 week, 2 week time frame I told you about, everyone sits at the table. The developer would connect his or her laptop to the monitor, and everyone is looking at this. Everyone's looking at the screen. Okay. Or in another scenario, the Scrum Master would inform the project manager of the fact that the sprint has been completed. Then the project manager can start sharing links with the other people, the product owners, basically. It could be the CEO, the CMO, the CEO, the CTO, the marketing managers. Okay, so at this point, at the staging environment, the application is online, but it's not open to the public. It's only internal. And for everyone can start interacting with it, and basically everyone knows what stage the product is in currently. Then everyone sits together, especially the decision makers. Once they've interacted with the application themselves, they say, you know what? We're ready to put this in the hands of our customers. And then the application is moved into the production stage. Or like I said, it's live and everyone can see it. Now, you can actually have more than one stage. So for example, working environment, like I said, is the developer's computers. Staging is where you look at it internally, but you can have between the working stage and the production stage, you can have multiple stages. So for example, you can have something called pre-production, where let's say you're developing a product for your client, and staging is where you review it internally. Pre-production is where you review it internally along with your client. And then when the client is happy with the product, then you go into production and the world can see it. Okay. Also, the staging environment is where QA, the software engineers whose job is specifically to test the components. This is the environment with which they will interact. So let's look at this. Let's look at these environments with a little more detail, and in this particular illustration, to understand this pictorially at least. Again, this is the working environment. Like I said, it just means the laptops or the computers of the developers. And here's how that process, this is what the flow looks like. Okay. Developer A is working on a particular component. Let's say the registration screen. They've taken the designs from the designer, and now they're turning it into code. We have another developer B, who's working on the landing page, the home page of this application. They do not exchange code directly. They don't like put it on a piece of USB or email the code to their colleague. Rather, they use a system called Git. Git is the name of a technology for version control, controlling the versions of your applications. Basically, what it does is it takes a screenshot. Okay, this is I think an actual screenshot. I'm just using this so you have some picture in your mind. It takes a screenshot of the code every time the developer makes a change to the code. In other words, every time the developer changes something in the code, we have a record of it. It's in the history. Even if they will put so much the space in the code, this Git technology will record that action. So every change that has been made to the code has been saved. Every time a developer completes a task, they will push their code. This is a technical term. They will use Git technology to push the code to a Git-based server. A server is, the word server basically is simply a computer, but these are computers. They're computers like your laptop, except they don't have any monitors, they don't have any keyboard. They're designed specifically to store large volumes of files and receive large volumes of bandwidth. Lots of users will interact with these servers. So companies whose servers are specialized for this Git technology include the very popular GitHub. You may have heard of this name. It's a company that is now owned by Microsoft. But other companies exist like Bitbucket and GitLab. So these platforms are specifically designed for hosting Git-based projects. So for example, when you upload, or the correct term is push, when you push your code to a GitHub server, all of the developers can go onto that platform and see what file was changed, what part of the code was changed, what time it was changed, who it was, and even they have the ability of going back to a particular time, or, for example, alternating between different versions. So for example, if a developer makes a mistake in the code and they push it to GitHub, in the staging environment, if the QA finds a bug, they will be able to trace specifically where that bug is, what caused it, and they can revert or correct it. Okay, so when developer A completes a task, they will to the Git server, GitHub, GitLab, whatever. And then the other developer B, will then pull the changes into their code. You will pull the changes, which means you have now integrated the changes of the other developer into your work. And then this developer will then push their code to the Git server, and this other developer will pull their changes. This way, everyone's on the same page. Everyone is working on the same project without contradicting each other, without conflicts, and everyone is able to keep track of everything. Now, when you are working with Git, you can actually have different versions of the applications. You can have different versions of the application. But let's say you have one version of your application. You have one version of your application. This version is then moved on to another platform where the servers are specialized for hosting the application. Okay, these are servers, these are computers, these are also computers. These computers are specialized for hosting the Git project, basically to keep track and facilitate version control. These servers are specialized for hosting your application. So for connecting the domain name, for resolving the DNS, for saving files, for saving the pictures of the users, their profile picture, for saving the data of the users, and that kind of thing. And of course, you definitely recognize the logos here. AWS, for example, is a company that provides this service. This is what we call, well, this whole thing is what we call this is what we call a cloud. These are cloud platforms. Okay, cloud means that the actual application is hosted not on the developer's computer, not on computers that you physically own, but are computers that are physically owned by another company. Companies that are specialized and have the hardware, the software, and the expertise to host your application and make it so that if you have hundreds of thousands of millions of visitors, those visitors will not experience any lag, no latency, and no downtime. Okay, so while you can host your own application, it's possible. It is not recommended. It is recommended you go with a cloud vendor. Now, we've actually recorded workshops on this topic. The links, which I'll share with you at the end. I'll tell you about that once we get to the end of the slide. But this is how it works. So you would push, or you would actually replicate the files in the Git server on either AWS or Azure or IBM Cloud or Google Cloud. And then, so basically you're going to set up this application. You're going to set up the application on these servers, and it is these servers, it is these computers with which the end users are interacting. So if you see here this picture of people who are on the app and they're typing and they're tapping in all of that user interaction, they're actually interacting with applications that are on the cloud. Okay. Now, if your intention, if after this workshop, or if you're already in the middle of developing something, I would also make a side note that you want to go with this particular platform, Heroku. Heroku actually uses AWS for hosting applications. They don't actually host it themselves. They don't have computers on which they will host these applications. They host it on the computers of AWS. But why would you want to go with Heroku? You see, if you want to host applications on these platforms, there is a learning curve. There is a certain level of technical expertise that even your software engineers may not have. That means you may have to bring someone else to do the work. Whereas Heroku is especially developer friendly. Okay. In other words, what the same technology that they use to get their applications on GitHub, Bitbucket, or GitLab, it will be the same set of techniques to get it on the cloud, and then eventually the your end users will be interacting with them. So take a screenshot of this particular slide, but nonetheless, we will be sharing the slides, and I'll tell you how we'll be sharing the slides. But let's move on quickly to the next steps. So at this point, let's assume that you know the problem you're solving, you know the people who are going to be using your applications, and you know what platform you want this application to be on. What particular programming language, what particular technology should you go with? We have many platforms. We have the Apple iPhone series. We have all kinds of Android phones. We, of course, have the web. And then we have the Windows operating system. We have the Mac operating system. And we have a whole host of Unix distributions like Ubuntu, Solaris, and others. You want to build an application. This is the let's say the what's the word I want to use? The great aspiration to develop the code once and distribute it on multiple platforms. So basically, you want a cross-platform application. Basically, if you want to build an app on iOS, you need to know Objective-C and Swift. And there are developers who know those particular technologies specifically. Whereas if you want to build an app for Android, you need to know Java. It is rare that one person actually knows both. And if they do, they're kind of stretching themselves thin. Not to mention another platform called application. An application developer has certain knowledge that mobile developers will not have, and vice versa. But there are platforms that actually make it possible. There are programming languages that make it possible for you to build the application once and distribute on multiple platforms. Let's look at some of these very quickly. For example, there is something called Xamarin. Xamarin is like I said, a platform, or let's say a set of tools in which you will program in a language called C#. Assuming you even know what C# is. Let's say you know C#, you can actually build the code, build the application once, and distribute on both iOS and Android. That's one option. Another option. This is something new developed by Google. It is called Flutter, and it's based on a programming language called Dart. Okay, this is something else you also may want to check out. This could be another good option for you. Flutter makes it possible for you to build the app once and distribute on iOS and Android and web. By the way, quick note: web is now the most popular platform. It is increasingly going to be take the biggest share of application users. So keep that in mind. Again, there's another workshop on this, which I will come back to later. But Flutter is another option. Flutter would be a good investment if you want to build an application once and distribute on 3 platforms. And then there's another one. Node.js. Node.js is a technology that allows you to program in a programming language called JavaScript and deploy applications for all the platforms, including ones that I have not mentioned here. Node.js is even used to build applications or program embedded systems. For example, a coffee machine or even robots. Okay. Now, these two are actually quite similar, Node.js and Flutter, because of their programming languages. Node.js uses JavaScript, Flutter uses Dart. They're very similar programming languages. However, Node.js has been around a lot longer. It has a much bigger community. And Flutter is still, in many ways, not... there's work to be done with Flutter. So if you need something to be developed immediately, Node.js would be a good investment. And the fact that it's built on, it's written in Java, it's programmed in JavaScript, makes it a good, makes it possible for you to future-proof yourself. Meaning, once you build this application, programming languages, and the fact that this programming language developed by Google is so similar to it, you can later easily transition to the other platform should you choose. This is also something we teach. This is the basis. This is the technology on which our Coding Bootcamp is based on. And now let me come back to it very quickly. But I want you to take a screenshot of this. These are the things you want to check out immediately after this workshop is over. These are definitely things you want to be familiar with if you want to build an app. So take a note of this. And by the way, we're almost running out of time. We have just launched a new channel on our Slack, a new thread in our Slack channel. I highly recommend you join the Slack channel because everything we talked about here is going to be shared there. And I'm sure that you have questions. Many of them. I'm sure you have any questions. You will want to join the Slack channel so that you can, we can continue this discussion after this workshops, and I'm sure you have questions. I'll be able to answer you over there. So I'm going to put this link here in the chat. Go ahead and make sure you join this. There's a channel called Open Academy. Make sure you join that one. Now, let me come back to the Coding Bootcamp. So, as you know, this is a program that we've been running, or maybe you don't even know this, but this is a program that we've been running here at AstroLabs since 2017. We now have almost 400 graduates. Okay, everything we talked about in this workshop and in the other workshops that we recorded, the links which will be shared on the Slack channel, all of those things are taught in this bootcamp. This bootcamp is a 2-month program which is designed for people who haven't touched a line of code in their life. Now, you could be a developer. I can give you an advantage, but even if you have no coding experience, you don't know anything about app development, this program is especially for you. Okay, and in this workshop, in this bootcamp rather, we will teach you the very basics of coding, and you will acquire enough skills such that at the end of the bootcamp, you would have produced an application of your own based on the very same technology we talked about, which is Node.js. In other words, by the end of this bootcamp, you would have acquired enough skills to build an application for any platform. The focus of this bootcamp is the web platform because, like I said, it has been, and it's going to continue to become the most important platform out of all other platforms. But because you're learning Node.js, and I told you that Node.js can be used on other platforms, you will also be able to develop applications on different platforms. So make sure to check out this link, go through the schedule, go through the modules, and check out the testimonials to see what our graduates have had to say about this program. And with that, I'm going to hand it over to Majid, who's going to tell you about the other offerings we have here at AstroLabs. So Majid, if you can take it from here, please.
Yes, sorry, just give me a moment. Sorry, just my camera turning on. Hi, everyone. So I'd just like to tell you a little bit about AstroLabs and the journey you can be taken with us. Since you're in this meetup now, you already know part of what we do, which is offer these 1-hour webinars. It spans different topics in the field. So you'll have, we have meetups about coding, about web development, about digital marketing, social media. It's a whole wide variety of it. Our aim from these webinars is to empower the tech community in the region. But these webinars are only one part of what we do. At AstroLabs, we offer courses. We have courses in a variety of different subjects. Some of them are foundationals. So the one you see at the bottom in blue here, these are foundational courses that are meant to introduce you to the subject and give you the practical skills that you need to work in the respective field of the course. So if you're looking to become a digital marketer, or if you're looking to do your own digital marketing for your own company, or brush up on your digital marketing skills, then the foundational digital marketing course would be great for you, because it's not a lecture. It's a very practical course where you come in, you do all the work, and you walk out of it ready to do all the work yourself in digital marketing. Besides these foundational courses that you see in blue, we also offer more advanced courses. So if you're someone who already knows their field, who already works in it, but are looking to become an expert at what you do, then these courses are the right fit for you. So if you're in this meetup right now, chances are the most relevant course to you is the Coding Bootcamp. It's a course where you walk in, you build a website from scratch with Danny. So you start from the basics from HTML, CSS, and then you go to JavaScript and you work on your own website on your own. You do all the work yourself. And then once you're done with that, we'll offer more advanced courses. So we'll be sharing a link very shortly, a form. If you put in your details in there, we'll reach out to you and we'll tell you more about the Coding Bootcamp. But just let us know what course you're interested in, and we'll reach out to you and talk to you about it. Once you're done with the course, it's not a short course where you just do it and that's it. You'll always be in touch with us. We have a lot of services that we offer for continuously upskilling. So we'll have webinars similar to this, but exclusive to our alumni. So they're designed specifically for you to build on what you already learned in any of our courses. So we'll be sharing the form now in the chat. If you can just fill it out if you're interested, and let us know. The form is also a feedback form. It'll just let us know a little bit about what you thought of the meetup, what kind of new meetups you'd like to see, because that's how we decide what direction we take. It's just based on what you guys want to see, what you guys want to hear from us. And besides that, as part of our network, as our alumni, once you take the course, you'll have access to all the existing alumni from our previous courses, the companies that work from within our offices, from our co-working spaces. It's a very valuable resource where you can connect with people for different purposes, for partnerships, for jobs. We have a lot of founders in our network looking to employ, or if you're a founder yourself who's looking to hire someone, you can leverage our network and really be a part of this community in the region.
Great, perfect.
Okay,
Thank you so much, Majid. And with that, sorry, did you?
We just sent the form.
Okay, yes, do check out the form. And I just want to remind you, this is the first time we're actually announcing the Slack channel, the Open Academy. You definitely don't want to miss out, because it's free. You'll have your questions answered, and we will be we will be sharing some material that we will not otherwise be sharing outside of the Slack channel. So make sure to check that out. Make sure to fill out the survey. And with that, I want to thank you all for joining us in today's workshop. I look forward to discussions on Slack. And until the next workshop, everybody, have a great day and bye-bye.